Good morning. In today's session, we are supposed to study about the three-phase induction motor. This type of motor we are saying as a AC motor. Here we are supposed to study about the three phase. There are two types of the induction motor, single phase and the three phase. If we are giving the supply, that will be the three phase. We can give that supply in two ways. We can give that supply in the delta connection or we can give that supply in the star connection. It is depending on us how we are giving that supply. So if we are giving three-phase supply to the three-phase induction motor, at that time we are supposed to give that supply to the three-phase stator winding. So we have seen already, we have seen the construction of three-phase induction motor. It will consist of stator and rotor. In stator, there is a stator frame, there is a stator winding, there is a stator core. And we have seen we are using their rotor that will be as a main winding, or we can say the armature winding. So here when we are giving the supply, that will be the three phase. At that time we can say we can give that supply by using the sequence for the phase. If we are using the three phase, at that time we can call that as a RYB phase. Here you can see I have drawn the diagram. Okay, so you can see here when we are giving the three phase supply, we are giving that supply to the stator winding. This is the DC motor, so we are giving here supply to the winding. So what we are saying here, when we are supposed to give supply, that will be the three phase. So we are supposed to divide the 360 will be in a three phase. So we are taking here 120-degree phase. So here we can give that phase that will be by using the R, Y and B. R for red, Y for yellow and B for blue. At that time, we can give that supply by using the sequence RY. Here I am using the letters A, B, C. But if A is nothing but here we can use the red wire. Here you can use at the B yellow and at the C you can use B is nothing but the blue. It means when we are supposed to give three-phase supply in the three-phase induction motor, at that time we can use the phase sequence that will be RYB. ABC ki jagah actually in practical what will be? Here you can give the sequence that will be RY. This sequence is very important. The question will come in the MCQs, which sequence we are using. Because when we are giving the RYB, at that time, that motor will rotate in the clockwise direction. And if you are interchanging the position of these three phases, which phases? The red, yellow and blue. If you are changing these directions, what will happen? The motor will get reversed to rotate in the direction. If it is rotating in the clockwise, if you are changing the phase, RYB, if you are changing the phase, instead of Y in middle, you are taking the first. If you are taking the YRB, if you are interchanging any two phases between these three phases, what will happen? The direction of that three-phase induction motor will get reversed. If it is going in the clockwise, now it will become in the anti-clockwise direction. So here we are supposed to take RYB sequence when we are supposed to rotate your motor. Okay, so here what we are saying here, when we are giving the supply that we can give to the stator winding, and here we are taking three phases and the magnitude of the voltage in each phase will be equal. So we are having total 360-degree. We are having three phases. We are taking here ABC, but practically these are nothing but R, Y and B. And what we are saying, when we are supposed to use three-phase supply, at that time we will require all these magnitude of these voltages should be in equal. So 360 divided by 3, you will get 120-degree for each. So you can give their voltage for each phase that will be 120-degree. And if you see the two adjacent phases like R and Y, if you see Y and B, that will have the voltage that will have the phase difference between these two adjacent between these two, that will be 120 degree. So here we can say we are giving the three phase supply by using the R by B phase sequence, in which we are giving all these three phases the equal magnitude of voltage, that will be the 120 degree. And if you see the two adjacent phases, that will have the phase angle of voltage between two adjacent phases, that will be the 120 degree. So here, if if we are deriving the value of current for R, it means what? That A. If you are deriving, you can write the equation. How you can write? You can write, if you are writing the equation for current for that red phase, A phase, you can write IA or IR equal to maximum current Im into cos omega t. But what we are saying? We are saying all are having the same magnitude of voltage. But if you see, we are using the three phase and adjacent two are having the 120 degree phase difference. So if you are writing the equation for Ia as okay. If you are writing the equations for Ia as, just wait for a minute, waiting कैसे आ गया? So here, if you are writing the equation for the current flowing through this A phase, Ia equal to maximum current Im into cos omega t. You are saying there will be the 120 degree phase difference between B and A. Please mute yourself because this concept is not that much easy. What we are saying, because you are supposed to write theory also with this diagram. When we are supposed to there will be the question on explain the working of three phase induction motor. At that time, you are supposed to write how you are giving the phase supply and how these phases will related with each other. That's why I'm saying, okay. So what we are saying, if we are writing the equation for the current flowing through this phase A, IA, equal to IR, because this is the red phase, this is the Y phase, and this is the B phase, because we are using RYB phase sequence. So if you are writing equation IA equal to IR equal to Im into cos omega t, you are saying there will be the 120 degree phase difference between B and A. So your equation for current flowing through B will become IB equal to Im cos omega t in bracket omega t minus 120 degree. Because there is phase difference between these two, that will be the 120. Now you are supposed to write for C. You are written for the first A. That will be 240 degree phase difference between these two. Because in B and C, in these two adjacent, there is a phase difference 120 degree. In between these two, there is 120 phase difference. So between A and C, between R and B, there will be the phase difference of 240 degree. So for C, you can write the equations IC equal to IB equal to Im into cos omega t minus 240 degree. So you will get here, if you are using the phase sequence R, Y, B for three phase supply, which we are giving to the three phase winding. At that time, if you are considering Im is the maximum value of phase current, at that time you will get phase current that will be balanced and they will have the RMS value. Who has mute? Okay. If you are considering here three phase, you are taking here sequence R, Y, B, and you are considering Im is the maximum value of the phase current. At that time, if you are considering all are having balanced current, at that time you can take RMS value of I, R, I, Y, I, B. It means what? IA, IB, and IC. If you are using here ABC letter instead of RY, you can balance this value like if you are taking the RMS value for all these equal, means IR equal to IY equal to IB, or you can take IA equal to IB equal to IC. It means what? when we are giving the three-phase supply to the three-phase stator winding of three-phase induction motor, at that time there is a phase difference of 120 degree between two adjacent phases. That's why if you are saying, I will show you another time. So what we are saying here, if we are giving that supply by using our, if you are taking A, B, C, you can take a ABC. Here A ka auxiliary part that you can take as A2 or you can take A1 dash. B1 ka auxiliary part, the second side, you can take as B2 or B1 dash. If you are taking here Y, you can take Y dash as per your wish. But what we are doing here, we are using the three phase. How? If you see A1, B1 and C1, this will look like a star because we are connecting one point commonly and we are directly connecting A here. We are connecting B. If you see here, we are giving the three-phase supply. How we are giving? We are giving the three-phase supply by using this A1, B1 and this C1. We are giving to the stator winding. I have shown here only the front view. That's why you are able to see only the phase A and A2 dash. Like this, we are giving B1, B2 dash. We are connecting C1 and C2 also. So we are connecting these three phases. At that time, what will happen? Your magnetic field will rotate. So there will be the question, explain the production of rotating magnetic field in the three-phase induction motor. At that time, you are supposed to draw this diagram. You are supposed to explain how we are giving the supply, how we are taking that three-phase, and these are in equal magnitude. At that time, if you see here, when we are taking the equations for the current for the IA, IB, and IC, we are saying we can take equal value for the RMS value of the current for IA, IB and IC. At that time, when we are giving the three-phase supply, we have seen two adjacent phases are in 120-degree phase difference with each other. If you see here, A and B, there will be the 120-degree phase difference. And B and C, there will be the 120 phase difference. So when you are connecting like this, that motor will rotate in the clockwise. You can see here. First, it is here. After that, it is rotating like this. Again, it will go to the upward. Again, it will go the same directions. Again, it will go here. Again, it will go here. Again, here and again here. You are just understand what we are taking here. We are considering three-phase induction motor. That's why we are supposed to consider three-phase. That's why we are taking here three-phase. A ka other side we are taking A2, B ka other side B2, C ka other side C2. How you are write? You can't write. यहाँ पे तुम A1 है, यहाँ पे तुम B2, यहाँ पे C2. You can't give. You are supposed to take 120 phase difference between A1, B1, B1 and C1. So firstly, you can draw this A1, after that B1, after that C1. After A1 से perpendicular exactly 180 degree A2, B1 से exactly 180 degree B2, C1 से exactly 180 degree C2. Only you are supposed to understand one diagram, you will get this diagram. How? Because when we are giving RYB phase difference, it means ABC. At that time, it will rotate. What will rotate? The magnetic field. How it will rotate? If you see here, we are giving here three phase and there will be the 120-degree phase difference between two adjacent. So here if you see, when you will get here, if you are taking, you can consider from any direction, sir. You can consider from this direction, you can consider this, but when you are taking this rotating magnetic field, firstly, when you are using the RYB or ABC sequence, at that time, you are supposed to give A1 as N, B1 as N and C1 as N. And the next pole will become yes, because there is a concept of winding. So there is a concept of magnetic field. So when you will get the magnetic field, if that field is behaving as a magnet, how it will behaving as a magnet? If you are taking the two poles, that will be the north and south. So you are supposed to consider here N and you are supposed to consider here. Yes, like this. If you are considering firstly this direction, so there will be, when you will get the second will consider when b1 phase will move, there will be the 120 phase difference. ये डायग्राम बाद में ड्रॉ करो, ये नीचे वाला, the following diagrams you can draw later. Firstly, concentrate on this above diagram. So here when you are drawing the first diagram, the for A, after that what we are saying? We are saying B phase is starting after the 120-degree phase difference. After that C is starting again, there will be the 120 phase difference between B and C. And if you are taking from the A, there will be the 240 phase difference. So here, when you are drawing the diagram for the rotating magnetic field for the phase B, at that time, you are supposed to draw DC motor as it is. You are supposed to draw DC motor as it is. Only what will be the difference? ये यहाँ पे था arrow, there will be the 120-degree difference. If it is here, if you are taking downward, it will become 90. Again, you are supposed to take 30. That's why we can take that arrow like this. Again, what we are saying? Again, after that, you are supposed to consider about C phase. So you will get here, C phase will be 120-degree phase difference with this B. So you will get again 120, so it will go up. Again, you can repeat first, second, third. First, second, third. Again, you can get the first. Like this, you will get how your rotating magnetic field will rotate. Because when we are giving the three-phase supply, at that time, two adjacent phases are having the 120-degree phase difference. So here, your magnetic field will rotate in the clockwise direction. And if you are supposed to change the direction, how you can change? You can change the direction of the power supply. If you are giving the RYB phase sequence for the clockwise, and if you are supposed to change the direction, at that time you can change that direction by changing the sequence. ये ABC की जगह you can do ACB, or you can take PCA. You are supposed to only change the sequence. At that time, your rotating magnetic field will change the direction of rotation. So here we are saying we are changing the directions of rotating magnetic field by only changing the phase direction. So here when we are saying our magnetic field is rotating, at that time, if that magnetic field is rotating in the clockwise directions, at that time you can change the direction. How? By changing the direction of the power supply. So here if you see working principle of the induction motor, when you are using the three-phase supply, you are giving to the stator winding. At that time, there will be the formation of pole because there is a magnetic field. So there will be the north pole and there will be the south pole. So you will give three-phase supply to the stator rotating magnetic field. Stator will not rotate, but the magnetic field which is produced in the stator and rotor, it will start to rotate. Magnetic field will rotate and rotor part also will rotate. Rotor part means what? The main winding, or we can say the armature winding. So when you are giving the three-phase supply to the induction motor, at that time the magnetic field of the stator will rotate. Also that rotor part which will connected with this stator will also rotate, which will form two poles. These are nothing but the north and south pole. So here, when that part will rotate, you are not able to see here. You can see here. If what we are saying here, when we are giving the three-phase supply, at that time there is a concept of magnetic field because here we are using the stator and the rotor in the induction motor, and when we will give the power supply, at that time conductor will cut by the magnetic field. That's why there will be the production of magnetic fluxes according to the Faraday's law. So here that stator will not rotate, but it is forming the two poles, north and the south, and here it is generating the magnetic field. So that magnetic field will rotate. I have shown here the direction. if it is moving in the clockwise direction. And we have seen we can derive the direction according to the Fleming right hand rule. We can derive the direction for the EMF, induced EMF. So here, if you are saying magnetic field is moving to the upward direction, when we have studied about the working principle of DC machine, at that time we have seen if we are supposed to change the direction, how we can change, we can change the direction of given supply. इट मीन्स व्हाट, जो पावर सप्लाई दे रहे हैं उसका डायरेक्शन हम चेंज कर सकते हैं. एदर we can do this or we can change the direction of this magnetic field. So here also the same concept. When we are giving three-phase supply, these three phases we are using RYB phase sequence, in which two adjacent phases are having 120-degree phase difference. So if we are saying the two-pole stator is considered as the angle between the two adjacent. So here if we are considering these two, A and B, are adjacent, so we can say the angle between those two, which is having the 120-degree phase difference. So if you are calculating about the force, because we have seen the torque equation in the DC motor, like here, torque equation DC motor में क्या मिला था equations? You will get torque equal to F into R into sin theta. How you will get? When you are saying your DC motor, when we will give the power supply. Now I am explaining about the DC motor, which we have studied in our third unit. What we are saying, when we are giving the power supply to the DC motor, torque is nothing but it is the quantitative measurement of force and the radius. Radius is nothing but the perpendicular distance when your magnetic field will rotate. So you can take mathematically torque equal to F into R into sin theta. Or you have seen you can take mechanical power PM equal to EB into IA, back EMF into armature current. Or you can take mechanical power in the form of torque and angular velocity, tau into W. When you will get the DC motor, at that time only you will get the working for the induction motor, because all these things are the same concept. Only there we were using the single phase, but in our syllabus for three-phase induction motor, we are supposed to study about the three-phase supply. There is additional part. Here we are giving the three-phase supply. वहां पे हम सिर्फ एक फेज दे रहे थे, यहाँ पे हम थ्री फेज दे रहे हैं. तो वहां पे एक इक्वेशन मिल रहा था फोर्स का, एक इक्वेशन मिल रहा था वहां पे, बट हियर यू विल गेट थ्री इक्वेशंस for A, for B and for C. If you are taking the current equation for A, IA equal to Im into cos omega t. In that way, if you are considering two-pole stator, it's considered with angle between adjacent phases. These are 120-degree. Because you are considering in A and B, there is a 120-degree phase difference. So you can take their EMF R. If you are considering FR, this is nothing but FA. You can take maximum force Fm into cos omega t. You can take for B Fm into cos omega t minus 120. For C, you can take cos Fm into cos omega t minus 240 degree. In that way, you will get the resultant MMF for all these, because we are saying these all are oriented in the same space along the magnetic axis, but they are having the 120 phase difference between the adjacent. So here you will get all the equations. But what we are saying, when we are calculating the value of force, you can take omega equal to, what you can take? You can take omega equal to 2 pi n, like we have seen in the DC motor. Omega is nothing but the angular speed. It will related with the rotating magnetic field. Omega is angular speed. You will get omega equal to 2 pi n. N is nothing but small n, rotation per second. So you can take here omega 120 degree upon 3, because here we are taking the three phase. There we are supposed to take directly, we were taking omega equal to 2 pi upon t, or you are taking 2 pi n. But here you are taking the three phase. So here you are supposed to take omega equal to 2 pi upon 3 into 120 degree into n. 2 pi n into 120 degree upon 3. You can take for the three phase induction motor. So you will get here equations for the omega, that is nothing but 2 pi upon 3t into 120 degree. If you are writing in the term of time, you can write. So here, what we are saying, when we are giving the three-phase supply to the three-phase induction motor, at that time, you can see here, when we are giving the input, at that time, if your magnetic field is rotate like this, and your magnetic field is having the directions in the upward direction, at that time you will get here induced current that will be inducing because of that rotating magnetic field, and it will move in the rotor conductor. So here, when that conductor will cut by this magnetic field, there is a generation of the magnetic flux around this induced current. So you can see here around this you will get the flux due to the induced rotor current according to the Faraday's law. You are supposed to draw diagram step by step. Firstly, we are giving here supply, three-phase supply. At that time, there is an introduction of magnetic field which will move upward direction. At that time, magnetic that conductor will cut by that magnetic flux, magnetic field. That's why there is a generation of magnetic flux. So that flux will introduce just because of rotor current. So here there is an addition of higher fluxes, and due to which there will be the cancellation of two fluxes across Y and P, and there will be the addition of fluxes at the arcs. So you will get here magnetic mechanical force. So we can say when we are giving the three-phase supply to the three-phase induction motor, at that time, if we are using the sequence for the current like R, Y, B. Just wait for a minute. My voice is not coming clearly.
No, it's
Sorry,
okay,
ma'am.
ma'am.
आ रहा है या नहीं आ रहा है देवेंद्र?
आ रहा है मैम.
ओके ओके.
Hello.
How you guys are doing the lectures? I didn't get it because there is lots of voice. Okay. So you can mute yourself and just focus on it. What we are doing here, we are supposed to study about the working principle of the induction motor. When we are studying about the induction motor in our syllabus, only we are supposed to study about the three phase. We are using three phase by using the R, Y and B phase sequence. So here, when we are giving the phase sequence of the current, that is R, Y, B. Resultant MMF, that is nothing but we will get that force that will be moved from the axis of leading phase to that of lagging phase. It means what? Here you can see it will move from leading to the lagging phase. It will add that fluxes, higher fluxes in that area. So you will get this production of rotating magnetic field. This production of the rotating magnetic field also we can draw by using the three phases. Devendra is writing, he is not getting my voice. But remaining students are saying they are able to hear. So there will be network issue. हाँ, आपके वहाँ नेटवर्क इश्यू रहेगा. ओके. So here, what we are saying, when we are giving the RYB phase sequence, at that time their resultant MMF will increase and it will go from leading phase to the lagging phase. So here we will get the production of rotating magnetic field, and here if you see, when we are using the RYB phase sequence, that will be in the sinusoidal wave, because here we are taking the three phase. Here we are using the three phase which we are taking in the sinusoidal. So here that rotating magnetic field will also rotate. How it will be rotate? It will be rotate in the it will be rotate in the leading phase to the lagging phase. So when we are supposed to study about the three-phase induction motor, there is a new concept, like you are supposed to study about some parameters, like you are supposed to study about the slip, you are supposed to study about the torque equation. So here you can call slip, you can denote by letter small s. If you are saying torque is nothing but it is the torque which is produced when motor will start. When motor will start, it will be the quantitative measurement that we can take as F into R into sine theta. We have seen this thing. So what we are saying, when we are starting the motor, at the start, there will be no speed because motor will not rotate. Because what we are saying about the three-phase induction motor, we are saying three-phase induction motor will work as a self-starting. There is no need of any other starting device. This is the main concept here. Because of that reason, we are saying three-phase induction motor which will work as a self-starting. So here at the start, there will be no speed. At start, we can take speed equal to 0. So if you are taking speed equal to 0, what we are saying about the speed, you can take speed that will be equal to ns minus n upon ns. You can call this as a speed. Ns is nothing but it is the speed which you can take, that speed revolutions per minute. And if you are taking small ns, you can call that as a speed which we are taking in the revolutions per second. And you can take n is nothing but if you are saying this is the speed, if you are giving the three-phase supply to the three-phase induction motor, but at start your speed is 0. So you will get their maximum S. If you are writing S equal to Ns minus N upon Ns, you can call this as the slip parameter which we are supposed to use in the three-phase induction motor. At that time, you will get S equal to Ns minus Ns upon Ns. If we are supposed to calculate percent, how will you do? You can multiply both the sides by the 100. You will get. So you can reconvert that equation to derive the value for the N. If you are rearranging, you convert, you will get the equation N equal to Ns 1 minus N. I have written the same equation, but only we are interchanging the position. So we are saying if we are not giving any supply or we are giving any supply at start, what we are saying, there will be no speed because we are not giving any external power supply. Three-phase induction motor will work as a self-starting machine. So here you will get speed value 0. That's why if you are taking here n equal to 0, n equal to 0, you will get s equal to ns upon ns, you will get s equal to 1. So you can say you will get s equal to maximum, slip equal to maximum at start. But if you are saying s equal to 0, you will get maximum speed because you will get n equal to ns. And if you see practically, it is not possible because when we are using the three-phase induction motor at that time, as we are not giving any external supply, its n will be 0 at start. So you will not get practically s equal to 0. So you will get s equal to max value, that will be 1. So here we are saying when we are supposed to study about the three-phase induction motor, at that time you will get the equation for torque also. In in DC motor, we have seen about the torque equation. How you can write torque equal to, you can write F into R into sin theta. Or another, how you can write? You can write PM equal to EBIA, back EMF into armature current. Or you can write PM equal to torque into W. W means angular velocity. You can write W equal to 2 pi. So if you are taking one constant term as a K, but there we are having the K equal to 1 upon 2 pi, but here we are using the 3 phase. तो हमारा W का इक्वेशन क्या था यहाँ पे 2 pi upon 3, 2 pi n upon 3 into 120. So you are supposed to take here K equal to 3 upon 2 pi n s. So you will get here torque equation. There will be no question derive the torque equation for the 3 phase. There will be question on some numericals, or there will be the question which will be short answer. So there is no requirement to derive. But in DC motor, you are supposed to derive torque equation. So you will supposed to write whole that step. But here you can directly write this torque equation. How we are writing here? We are writing torque equal to constant term K into E square. This is nothing but EMF, the induced EMF, into R2 upon R2 square plus SX2 whole square and whole square root. I have given here which term we are calling which. S is nothing but the slip, and S is nothing but it is the speed which we are measuring in the second, synchronous speed of the motor. We are measuring that speed in the second. We will see torque equation again in the next section. Just see here, just get some short idea. So what we are saying here, because we are having only 2 minutes. So here we are saying R2 is the rotor resistance, X2 is the rotor reactance, X2 is the reactance, and R2 is the resistance. So you will get the torque equations that will be equal to Ks E2 square R2 upon under root R2 square plus S X2 square. So here we are saying the value of rotor speed. The value of rotor speed will depend on the slip, because here if you see here you will get the slip value maximum, because we are saying at the start you will not get any speed. You will get speed equal to 0 for the rotor. Remaining syllabus we will see in the next session. I am taking your attendance. If anyone is facing any issue, you can ask me. We are having 1 minute. Okay. You guys can leave now. Thank you.